Thanks very much, Mary Frances, and good morning, everyone. I just wanted to begin with a reminder that our climate is already changing. So this is a graphic of the change in global temperature over the last 100 or so years. And each stripe represents the temperature averaged over the year. Blue is cooler than average, red is warmer than average, and then the intensity of the color illustrates the difference from the average. So you can see that the world has had cool periods and has had warm periods, but the warming that is observed has intensified over the past 2 decades. And then that means that the global temperature for 2019 was around about 1.1 degrees above the pre-industrial baseline. So what does this mean for Ireland? I've summarised some observations and projections on this slide. The temperature in Ireland has increased by at least 0.8 degrees. So that's in line with that global 1 degree trend we saw in the last slide. And the temperature is projected to increase across all seasons. Warm days and heat waves are going to occur more frequently. There's probably going to be, or it's expected that there will be a reduction in spring and summer rainfall. And that, of course, creates a drought risk. And this year we've already seen hosepipe bans, for example. But then it's anticipated that there will be a substantial increase in heavy precipitation events in winter and autumn. So as a consequence, flood risk, for example, will increase. So on average, the year might be drier, but when it does rain, it's going to rain differently, and it's going to rain through more heavy precipitation events. And then there's also going to be changes in sea level. And for our coastal areas, this is very significant because that is going to magnify the risks of changes in storm surges and wave patterns. And also the intensity of individual storms may increase. So with that in the back of your head, over the rest of the presentation, I'm just going to discuss climate risk and the links between mitigation and adaptation. I'll also talk about why we need to adapt and how we adapt to the locked-in impacts of climate change, and what the future climate might look like in a bit more detail. And then I'll also discuss adaptation and resilience policy in Ireland before I wrap up. This quote is from the UN Intergovernmental Panel on Climate Change, the IPCC. It's from their 5th assessment report. And I just put this up because it highlights some of the messages that I want to focus on today. 2 things: it's going to amplify existing risks, but it's also going to create new risks that we've not experienced before. And there's an equity element to this that is very important. The risks of climate change are unevenly distributed. So least developed countries, small island states, are particularly vulnerable to the impacts of climate change. They've got the lowest adaptive capacity, so they're least equipped to prepare for climate change. And then at the same time, these are the countries that are contributing the least to greenhouse gas emissions. And the second message from it is that these emissions are going to have, or high emissions are going to have negative impacts on a range of systems, from biodiversity, economic development, livelihoods, and food security. This is another IPCC slide, and it shows their climate risk framework. Now, I know it's a busy slide, but the key takeaway is that changes in the climate system on the left are driven by emissions at the bottom. And then you've got adaptation and socioeconomic processes on the right. And these 3 things, or these 2 things, changes in the climate system, emissions, and what we do to prepare for it, and how we live our lives, and how we organise our societies, are the drivers of hazards, exposure, and vulnerability. And that's your climate risk in the middle. So just some examples: when we say hazard, we're facing more extreme precipitation events, like I said. Your exposure is that you might have housing in floodplains or areas that didn't flood before but may flood in the future. And then you've got vulnerability. So that's, are these houses in floodplains designed for this? Is there flood insurance in place? And things like this. But what this slide does make clear is that adaptation and mitigation are required to reduce the risk of climate change impacts there in the middle. But when I'm talking about adaptation and where it fits in with mitigation, what do I mean? Well, we know that if warming is limited to 1.5 or 2 degrees, there will still be unavoidable impacts. And as I said, we've already seen some of them. Adaptation is going to address current risks, but also future risks posed by a changing climate. It's about reducing the vulnerability of our environment, our society, our economy, and it's about increasing resilience. Mitigation, as Laura mentioned in her opening address, reduces the rate as well as the magnitude of warming. So it increases the time that we've got available for adaptation, potentially by several decades. But instead of treating them separately, which can happen, it's essential that climate policy considers their relationship. So, do your adaptation actions impact on your mitigation objectives? A very poor example would be air conditioning. You increase air conditioning, you're going to increase emissions. How do we ensure that an electricity grid with more renewables, a more dispersed electricity grid, how do we ensure that that remains resilient? And then how do mitigation actions affect adaptation? So how do we ensure that more airtight, more efficient houses don't overheat in the hotter summers that we're going to face? And then it's how they work together as well. So you've got areas like spatial planning, health policy, and how we can target investment to make sure that a healthier and a greener city is also going to be a more climate resilient city. I wanted to flash this climate action tracker thermometer up. You'll see with the arrow that we're at about 1 degree of warming, as I said. And in the middle bar, as Stephen and Laura mentioned, it's about 3 degrees or so by 2100 is the median of current global climate policies. And then up to last year, if we include all the pledges to reduce emissions, even if fully implemented, it brings us down to about a 2.8 degree rise in global temperatures. And clearly these figures are well ahead of the Paris goal to hold the increase to well below 2 degrees and to pursue efforts to limit it to 1.5 degrees. So what this in a nutshell shows is that we need more commitments to get onto a pathway compatible with 1.5 degrees. It is worth saying that even then there is uncertainty about the climate system and how it reacts to emissions, and that means that there still would be a small chance of 4 degrees or more warming by 2100. In 2018, the IPCC published their special report on global warming of 1.5 degrees. And this confirmed that even though it might seem small, there's actually a big difference between the impacts at 1.5 and at 2 degrees. And that's in areas like average temperature, frequency of hot extremes, heavy rainfall, probability of drought increases as you go to 2 degrees. The risks are also greater if we overshoot 1.5 and come back down to 2 degrees, rather than if we gradually stabilize warming at 1.5 degrees. And also the last point there is that global economic damages are significantly smaller under warming of 1.5 degrees compared to 2 degrees. This chart, again from the IPCC, represents the risks of 1.5 degrees, 2 degrees and beyond. And it does these across 3 or 5 RFCs, reasons for concern. I won't go into all of them, but the bars go from white, where the impact or the risk is undetectable, up through moderate in yellow, high in red, or very high risks in purple. And that grey line is again the 1 degree change where we are now. So as I said, I won't go through all of them, but RFC1, for example, unique and threatened systems, that covers coral reefs, for example. And you'll see that there's a very high risk of severe impacts for things like coral reefs at close to 1.5 degrees and beyond. And that H then is that it's with high confidence. RFC2 is extreme weather events like heat waves, heavy rain, drought, wildfires, coastal flooding. And again, you'll see the risks increase as the temperature change increases as well. The blue text is examples for the other RFCs, which you can look at yourselves. And then when it comes to EU level, there's some recently published figures from the Commission's Joint Research Centre, a project called PSETA, and that shows what meeting the Paris goal would mean for Europe. So if we meet the Paris goal, for Europe, annual drought losses would be reduced by 20 billion a year. Coastal flood losses would be lowered by more than 100 billion a year in 2100. And the damages from river flooding at 1.5 degrees are half those damages compared to 3 degrees. And then the number of people annually exposed to dangerous heat waves, it reduces by 200 million if we meet the Paris Agreement goals, and it's estimated that there will be 60,000 fewer deaths per year. And just on heat waves, these figures are from the World Weather Attribution Network. And this looked at observations and climate model simulations to see or to estimate the impact of climate change on the extreme temperatures in Europe last June and July. There was also a record-breaking warm spell in February 2019. And the World Weather Attribution Network found that every heat wave occurring in Europe today is made more likely and more intense by human-induced climate change. It looked at the heat wave in France and the Netherlands, and it found that that was 100 times more likely than without climate change. And it was at least 10 times, made 10 times more likely because of climate change. It looked at the heat wave in the UK and Germany last year, and it found that was 10 times more likely because of climate change, or at least 3 times more likely. And it's important to remember as well that the 2003 European heat wave caused something like 35,000 excess deaths. So, you know, extreme heat is as deadly as the cold. So then quickly to bring this back to Ireland, the next couple of slides are from Ireland's climate information platform, Climate Ireland. And this slide shows a map of Ireland and the changes in average winter precipitation in a high emission scenario, and this is aligned with RCP 8.5. And this is looking at, it's one model looking at a high emissions future, and it's looking at what the difference in precipitation in winter would be in mid-century 2041 to 2060 compared to the past period 1981 to the year 2000. And what you can see with the blue and the darker blue is that average winters mid-century will be wetter pretty much all across the country, but particularly in the west and southwest. And this is again in a high emissions scenario. This slide then shows the average winter precipitation mid-century in a medium emission scenario. So it's modeled on RCP 4.5. And you can see that there will be an increase in winter precipitation, but again, it's not as severe as the higher emissions scenario. And again, this is comparing in that medium emission scenario, mid-century rainfall compared to the past period, 1981 to 2000. And these are both alongside each other, and you'll see the importance of reducing emissions. It'll mean less impacts, less risk, less adaptation, more time to prepare for the new normal. I will say that neither of these scenarios represents the strongly declining emissions that are needed to achieve 1.5 degrees, and if that's achieved, the increase in winter precipitation could be less. And if you're into this sort of thing, Climate Ireland lets you play around with these, and you can have hours and hours of fun doing maps for things like heat in a number of different scenarios, and I'll mention Climate Ireland again in a moment. So the last piece of the puzzle that I wanted to talk about was adaptation policy and the implementation of adaptation in Ireland. So at the top there, you'll see that the 2015 Climate Act and its aim of a climate resilient economy is the basis for national adaptation policy. Under the Act in 2018, the government produced a national adaptation framework, and that called for sectoral and local plans. The framework identified 12 priority sectors across a number of departments, and last year 9 plans were published covering those 12 sectors. And you can see the covers there on the right. Each local authority also now has a local adaptation strategy, and they were developed alongside or with the assistance of the Climate Action Regional Offices. What you will see also is that across the 12 sectoral plans, excluding the local plans, you'll see that there's 180 actions in the plans covering those 12 sectors, and ensuring that they're delivered, funded, coordinated across sectors, but also up and down to local and regional level is going to be a very significant challenge. And these have a 5-year lifespan in line with the National Adaptation Framework. And the Climate Change Advisory Council has a role in advising on adaptation and the preparation of sectoral adaptation plans. And late last year, it produced a short report on the adaptation planning, the adaptation plan preparation process. And that found a couple of things which I think are interesting. it found that adaptation is expensive, but inaction is likely going to cost more. And this is something that came from the Stern report all the way through. In terms of planning for climate change and planning for adaptation in Ireland, we're making good progress, but there are gaps. So there's no sectoral plan for some areas like tourism or sport or housing, for example. Or else there's also areas where responsibility is divided across a number of departments and agencies. So coastal change, how we prepare for the changes to our coasts due to climate change, is spread across a range of different departments and agencies. And there isn't one sectoral plan covering this, but that's a challenge most countries are facing, but it remains a gap. Something else the Advisory Council report found is that the need for adaptation is under-recognised in government policy, and that it needs to be integrated across all plans and programmes, including identifying the appropriate resourcing. And this is mainstreaming, and this is a key part of adaptation theory, is that it needs to be mainstreamed across investment decisions, across policy making, across all areas. And while government departments and local authorities are putting these plans and strategies in place, the Advisory Council also flagged that the private sector and household adaptation decisions will also be very important. So what roles do businesses, organisations and individual households have in making sure that they're climate resilient? And you have this idea of every winter, be winter ready. There is possibly scope there to advise individuals and households how to be climate ready, and as I said, if there's more heat waves, how to be summer ready, because that can be very dangerous for vulnerable people too. And then the last thing that I pulled out of that Advisory Council report was that decision makers need to look at a range of global warming scenarios when they're making decisions and when they're looking at investments, and that includes those with higher warming. You looked at the thermometer, there's a big range there between the 1.5 and what it could possibly reach. And last week, the UK Climate Council, so the UK's equivalent of the Climate Change Advisory Council, advised the UK government that it should plan for a minimum of 2 degrees, but it should also consider 4 degrees. So that government decision making in the UK should be done on the basis of 2 degrees, but also it should be with a view to ramping up the adaptation investment and decision making if temperatures were going to reach 4 degrees. So very quickly, I just wanted to flag up that there's a lot of resources in this space and some other developments. There's a number of EPA funded research publications on the EPA website at that link. That third bullet point, indented bullet point there, that Nolan report from 2015, that informs the Climate Ireland maps that I showed you, and that'll be updated shortly, and that'll carry across to Climate Ireland. Over the last few years as well, Europe has invested in research for the development of climate services, and that's really about how you make complex data scenarios usable for decision makers. And JPI Climate and Copernicus are key European players in this space. And you might have seen reference to Copernicus data very recently. It was in the news, I think, yesterday, because showing that June temperatures in Europe were again record-breaking. And also the Copernicus satellites tracking the drought in the Czech Republic, because the Czech Republic is experiencing the most severe drought in its modern history. And then finally, just to flag 2 things at EU level here. Horizon 2020, the successor to Horizon 2020, Horizon Europe, includes a mission on adaptation and societal transformation, and there'll be projects falling out of that. And then under the European Green Deal, there's going to be a more ambitious EU adaptation strategy early next year. And that's going to look at the direct and indirect impacts of climate change for Europe, but also there is implications for trade, climate migration, and other spillover effects. And then, just as I wrap up, this quote is from a grouping called the Global Commission on Adaptation. It includes people like former UN Secretary General Ban Ki-moon and Bill Gates. And the key message from their 2019 report is that it's not an alternative. Adaptation is not an alternative to stopping climate change, but it's an essential complement to it. And done right, it'll lead to better growth and development, save lives, and reduce inequalities. And then finally, I'll finish with these. So As we saw at the start, we're already seeing the negative impacts of climate change, and adaptation is required due to the effects of past emissions, but also ongoing emissions. So adaptation is necessary even if we were in a zero emissions world now. It amplifies existing risks, it increases and creates new ones. Adaptation and mitigation together are essential, but their relationship has to be considered closely in policy. And then finally, successful adaptation requires planning for a range of future climate scenarios. Well-planned early adaptation saves money, disruption, and potentially lives as well later. So, Sinead, and thank you for your attention, and I look forward to your questions at the end.